So this will be the third video in the series on measurement conversion. So the focus of this video is going to be measuring weight and temperature. And one thing we haven't done in a little bit is convert strictly within the metric system. So the first video that we did, we converted strictly within the English system, strictly within the metric system, and then we converted between the two. In the previous video, we only really converted between English or English metric. So we didn't get any practice just converting within the metric system. So I want to practice that. Then we'll do some other conversions, and then we'll look at converting just temperature, which is pretty easy. So converting between Celsius and Fahrenheit. Okay, so let's go to the whiteboard. Now, a quick reminder, within the metric system, remember that's where we have the basic unit, meter, liter, gram, and then we have the prefixes, kilo, hecto, deca, basic unit. So in this case, we're talking weight, so it'll be the gram. And then we have deci, centi, milli. Okay, so let's do a quick recap of that. So the basic unit for weight is the gram. So within the metric system, the basic unit for weight is just a gram. Okay, so then we have kilo, hecto, deca. We have a single gram. We have a decigram, centigram, milligram. So this is 1,000 grams. This is 100 grams. This is 10 grams. This is just 1 gram. This is 1/10, 1/100th, 1,000. Okay. So if you'll remember, the way I was able to convert is I would keep this kilo, hecto, deca, and so forth somewhere in front of me. So I had the order. And remember, if you're struggling to remember the order, it's King Henry died by drinking chocolate milk. So that'll help you remember K for kilo, H for hecto, and so forth. Okay. So I just keep this somewhere nice and organized, or as nice as you can do when you're using this dreadful stylus on this particular laptop. All right. And I just keep that in front of me, and that helps me figure out where I'm at and where I need to go. Okay. So let's say we have 4.2 decigrams, and we want to convert to milligrams. Now, you do have to be careful of the D's. There's decagram, which is 10 grams. There's decigram, which is 1/10 of a gram. Deca has a prefix of DA. Deci has a prefix of just D. So make sure you understand the difference in those, because it could be easy to confuse them. So for this particular problem, we're starting here with deci, and we want to convert to milligrams. So we need to move to the right twice. So you take your decimal and you move it to the right twice. So that tells me there are 420 milligrams in 4.2 decigrams. Okay. And then let's say we have 620 centigrams, and we want to convert to grams. Okay. So same idea. We figure out where we're at. So we're starting with centigrams. Let me do it in red so it's easier to see. And we want to go to the gram, which is 2 jumps to the left. Okay, so I'm going to take my 620. I don't see a decimal, so I put it at the end, and I move my decimal to the left twice. Okay, so that tells me 620 centigrams is the same as 6.2 grams. Okay, so that's just a quick review of how to convert within the metric system. And again, in this particular section, we're specifically measuring weight and temperature. So that's why I focused on the gram here. Okay, so now moving forward, again, for this video, we're going to focus, let me do black ink. That's a little easier to read. We're going to focus on measuring weight and temperature. Now, for the most part, when we're converting in all 3 sections, all 3 videos, the bulk of what we're going to do involves dimensional analysis. So remember, dimensional analysis is the process of converting from one unit of measure to another by multiplying by 1 or more unit fractions. And remember, unit fractions are fractions that have a value of 1. So that means the top is equivalent to the bottom, but the top and bottom are made out of different units of measure. So the easiest example is 12 inches and 1 foot. I could make a unit fraction where it's 12 inches over 1 foot, 12 inches is the same as 1 foot. So they measure the same length. The value of that fraction is 1, but the top and bottom are made out of different units. Okay, so kind of remember that process because we're going to do a good bit of that for the next few examples. Okay, so for this one, we have that an aquarium holds 0.145 cubic meters of water. Okay, we want to know how much that weighs. Okay, so we're going to end up going to kilograms. Now, let's go and find our conversion sheet. So I'm going to pause this really quick so I can get my conversion sheet, and then we'll look at that. Okay, so I had closed out my conversion sheet, so I had to pull that back open. So let's go back to the problem that we had. So we're dealing with an aquarium. This particular aquarium holds 0.145 cubic meters, specifically of water. We want to know how much that weighs in kilograms. So let's go to our conversion sheet and we scroll down because we're talking about weight and temperature. Okay. And we have here that 1 cubic meter is equal to 1 kiloliter, which is equal to 1,000 kilograms. Okay. So right here, this is what we're looking for. So 1 cubic meter of water weighs 1,000 kilograms. Okay, so let's go back to the whiteboard. And remember, with dimensional analysis, you start with what you know. We know that we have 0.145 cubic meters. So I'm just going to write that as a fraction by putting it over 1. And then I'm going to multiply by a unit fraction that relates cubic meters and kilograms. Okay, and so from the previous conversion sheet, we know that 1 cubic meter is 1,000 kilograms. Okay, so 1 cubic meter is 1,000 kilograms. Okay, so we're going to cancel stuff, clean this up, and then we'll get our final answer. So the cubic meters cancel. We're left with our desired unit, kilograms, in the numerator. Okay. And then I'm going to clean it up. So for my numerator, I just get 0.145 times 1,000 kilograms. My denominator, when I multiply it, it's just 1. And I don't need to actually write that out because dividing by 1 doesn't really do anything. So as long as you show me your setup, you can do this on a calculator. Or if you remember how to multiply by powers of 10, I've got 1, 2, 3 zeros. So I move my decimal 3 places to the right. And we have that 0.145 cubic meters weighs 145 kilograms. Okay, so let's try another one. Let's do a somewhat easier conversion. I'll go to a new page. Whoops. So let's say that we have a person that weighs 120 pounds. You can use just pounds like this, or you can use LBS for pounds if you want to. But let's convert this to kilograms. So we go to the conversion sheet. And so kilograms are metric, pounds are US. So we want to go weight US to metric. And I have here that 1 pound is approximately 0.45 kilograms. Okay, so we need that to create our unit fraction. So we start with what we know. We know we have 120 pounds. Again, you can use the LBS if you prefer. We're going to put that over 1. And then I need to multiply it by a unit fraction that relates pounds and kilograms. And we have that from the conversion sheet that 1 pound is approximately 0.45 kilograms. Okay, so we clean things up. My numerator becomes 120 times 0.45 kilograms. My denominator is just 1. You could put this over 1 if you want, but when you divide by the 1, nothing happens. So I'm just going to jump straight to the multiplication. And I get that 120 pounds is the same as 54 kilograms. This comes in handy a lot of times with medications because a lot of medications, the dosage is given to us so many milligrams per kilogram. But here in the US, we don't weigh ourselves in kilograms, we weigh ourselves in pounds. So doctors would then have to convert your weight in pounds to kilograms to then figure out the dosage that you would need. And we'll look at an example like that in just a bit. All right. One more example. Let's say that we have 500 grams. So just plain old G for grams, and we want to convert that to ounces. So OZ for ounces. All right. So grams are metric, ounces are US or English. So let's see if we can find a conversion. All right, so we have right here 1 ounce is approximately 28 grams. Okay, so we're going to use that to create our unit fraction. So let's start with what we know. We know that we have 500 grams. I'm going to put that over 1. I'm now going to multiply by the unit fraction that relates grams and ounces, and always be really careful where you put your units in your unit fraction, because here I want the grams to cancel. I've got grams, I need to cancel those out and convert to ounces. So I make sure in my unit fraction grams are in the denominator. Okay, so we know that 1 ounce is approximately 28 grams. All right, and from here we're just going to clean things up, do some canceling. So the grams cancel, I'm left with ounces in the numerator, which is exactly what I want. And then when I clean it up, my numerator becomes 500 times 1 ounces. My denominator becomes 1 times 28, so just 28. And then as long as you show me your setup, you're welcome to divide on your calculator. So I get right here, if I round to 1 decimal place, because I do get kind of a nasty decimal, rounding to 1 decimal place, I'm going to get that 500 grams is approximately 17.9 ounces. And that's it. So at this point in time, by the time you get into this section, you should be pretty well versed on dimensional analysis. So from converting from one unit to another using unit fractions, okay? So let's do an example, kind of like what I alluded to earlier, where we're dealing with a dosage of medication, okay? So for this example, the prescribed dosage of a drug is 6 milligrams per kilogram. Okay, so that's the dosage for an adult, okay? How many 200 milligram tablets should be given each day to a patient that weighs 150 pounds, okay? So we have how many 200 milligram tablets, pretend that looks pretty, should be given to a 150-pound patient. Well, we got to do a few things here. First and foremost, we need to convert the weight of this patient from pounds into kilograms, because our dosage is given to us in kilograms. So we're going to start with what we know. We have 150 pounds over 1. We need to multiply by a unit fraction that relates pounds and kilograms. So if you don't remember it from the previous example, we can go over to the conversion sheet. All right, so we have that 1 pound is approximately 0.45 kilograms, okay? So we're going to use that to get our unit fraction. So 1 pound is 0.45 kilograms. So let's clean things up, do a little math, and we'll figure out the weight of this patient in kilograms, okay? So pounds cancel, we're left with kilograms in the numerator, which is exactly what we want. The numerator becomes 150 times 0.45 kilograms. The denominator is just a 1, so we don't really have to do anything with that. So multiply. And this particular patient weighs 67.5 kilograms. So this is super important. This is what we're going to base our dosage on, okay? So we know that we need 6 milligrams per kilogram. So the second thing we need to do is figure out, well, how many milligrams of this particular medication would this patient need? So we're going to call this like part A. And then part B will be how many milligrams does this patient need? So we know we need 6 milligrams per kilogram. So what we want to do is take the weight in kilograms and multiply it by the number of milligrams we need per kilogram. So we're going to take 67.5, we're going to multiply it by 6. And we get that this person needs 405 milligrams, okay? So we know the weight of this patient in kilograms, 67.5. We know how many milligrams this person needs, 405, okay? Now the real question is, how many 200 milligram tablets should be given, okay? So we want to take the number of milligrams this patient needs. We want to divide it by 200 because that's how many milligrams are in each tablet, and that'll tell us how many tablets this patient needs. Well, if I take 405 and divide it by 200, I get 2.025. Well, we're not going to be able to give this patient 0.025 pieces of a tablet, okay? So we're going to say that this patient is going to need 2 tablets of this particular drug, okay? So here are kind of our 3 really important pieces of information. We had to figure out the weight in kilograms, we had to figure out the number of milligrams we needed, and then we used that to figure out how many tablets of this particular drug to give this patient, okay? So that's pretty much it for measuring weight. What we want to do now is measure temperature, okay? So we're really only going to focus in this video on Celsius and Fahrenheit, okay? So there are 2, I'm just trying to move stuff, make room on my desk. There are 2 formulas that you need to know. So if we have Celsius, like we want to know what Celsius is, we would be given Fahrenheit. So what you would do is you would take 5/9 times whatever your degrees are in Fahrenheit minus 32. I do want to point out, order of operations matters here. So you would take your degrees Fahrenheit, you would subtract 32, then you would multiply by 5/9. Now, for the opposite, if you're looking for Fahrenheit, that means you'd be given Celsius. You want to take 1.8 times whatever your degrees in Celsius are. And then you want to add 32. So you take your Celsius, multiply it by 1.8, and then add 32. You might see in a book this 9/5 times Celsius plus 32. It's the same thing. If you take 9 and divide it by 5, you get 1.8. And students just generally like dealing with 1.8 better than 9/5. That's it, but they're the same formula. Okay, so let's do maybe 2 examples of each, and then we'll call it quits for this particular video. Okay, so let's start with Celsius. So we're looking for degrees Celsius. Okay, so let's say that we have 59 degrees Fahrenheit, and I want to convert that to degrees Celsius. I don't remember what I said a minute ago. I might have told you we would have degrees Celsius and we would find Fahrenheit. I'm a liar. We have degrees Fahrenheit. We're going to find degrees Celsius. So we want to know what Celsius equals. So we're going to use the formula C equals 5/9 and then in parentheses F minus 32. Okay. So I'm going to get 5/9. In parentheses, I'm going to do 59 minus 32. We have to do the stuff in parentheses first. Okay, so I'm going to get 5/9 times. Well, 59 minus 32 is 27. Okay, and how you get your final answer, it's up to you. If you want to do some work with fractions, that's great. If you want to jump straight to your calculator, that is also great. I don't care how you get your answer, as long as you show me this, what I have on the screen right here, then you can just jump to the final answer. So we get that 59 degrees Fahrenheit is equal to 15 degrees Celsius. Let's do one more like this. So let's say we have 14 degrees Fahrenheit, and we want to convert that to degrees Celsius. Okay. So we want to know what Celsius equals. So we're looking for a C equals formula. And the formula is 5/9 times degrees Fahrenheit, which is 14, minus 32. Okay. You do have to do what's inside the parentheses first. So we're going to get 5/9, and then in parentheses, we get negative 18. I'm going to erase that and fix that 8 because that looks stupid. There we go. Okay, now notice here you have a positive 5/9 and you're multiplying it by a negative 18. The sign does matter. Your final answer is for sure going to be a negative here. Okay, now again, how you get your final answer, I don't care if you sit here and do some work with fractions on your paper or if you jump to your calculator. I'm okay either way, doesn't bother me one bit. But at the end of the day, you do need to get that your answer is negative 10 degrees Celsius. Okay, so watch out for those negatives. They can show up from time to time. Okay, let's jump over and do some where we have degrees Celsius, but we're going to be looking for degrees Fahrenheit. Okay, so let's say that we have 50 degrees Celsius, and I want to know what that is in degrees Fahrenheit. Well, remember, you have 2 formulas. I don't care which formula you use. I do find that students generally like this one better because you're dealing with 1.8 instead of 9/5. So that's generally what I do. But we need 1.8 times degrees Celsius. Once we figure that out, we then add 32. Okay, so F equals 1.8 times whatever your degrees are in Celsius plus 32. So then I've got to do 1.8 times 50, which gives me 90. I'm then going to add 32, and I get 122. So 50 degrees Celsius is a whopping 122 degrees Fahrenheit. So if you're traveling, I don't know, in South America, Asia, Africa, somewhere in Europe, I don't know, and you don't know what to pack, and you find out that the temperature is going to be 50 degrees Celsius, my word to you would be don't pack a whole lot. Shirts, like t-shirts and shorts would be ideal. Or tank tops and a fan. I don't know. Anyway, let's look at one more. So let's say we have -5 degrees Celsius and we want degrees Fahrenheit. Okay, same process. We want to know what Fahrenheit equals. So we're looking for F equals 1.8 times -5 plus 32. Well, you do have a 1.8 times -5. So you are going to get a little bit of a negative here. So we get -9 plus 32. And then -9 plus 32 gives us 23 degrees. So let's say you're traveling to Canada and they're like, oh, the temperature is going to be -5 degrees. For us, that's 23, still pretty cold. Okay. So there you have it. That's converting temperatures. Okay. I think 2 examples of each is plenty. So let's call that a wrap for this particular video. It's the same day, but I'm slightly more disheveled. Boy, it's been hot in this building and I look a disaster, but I don't even care at this point. So we've talked about overall, we've talked about measuring length. We did an introduction to the English system of measurement with dimensional analysis. We then looked at the metric system where we can just like move decimals. We talked about measuring area and volume. And then we wrapped up this series with measuring weight and temperature. Okay, so that's kind of it for our series on measurement conversions. Hopefully everything goes well. If not, reach out. All right, good luck.